Hello, my name is Vinayak Manoj Kurup. My topic here is machine learning based building energy prediction. The consumption of electricity has been increasingly at high rate, and traditional statistical method not be able to predict this consumption with accuracy. Therefore, it is important to predict electricity consumption with accuracy to ensure reliable electricity supply and optimize energy distribution and to avoid blackouts and brownouts. The project aims to predict the electricity energy consumption of domestic building by developing a machine learning model using past data on electrical consumption by different appliances sourced from Kaggle. The machine learning model will be developed using Python language. This project holds several objectives. The first objective is to perform a literature review of various ML techniques that can be used to predict energy needs of buildings. In several papers related to prediction of energy consumption were accessed and the technique used in them were determined. The accuracy achieved by authors was identified in related to their developed models. The second objective was to develop a machine learning model to predict the electricity energy consumption of the building using past data on the electricity consumption by different appliances sourced from Kaggle. This objective involves the use of machine learning techniques in order to predict consumption of electricity. I made use of stacking regressor to achieve this objective. The last objective was to evaluate performance of machine learning model using different accuracy metrics such as RMSE, MSE, and MAE. Different research papers were reviewed to know about various ML techniques used by authors to predict electricity consumption pattern of buildings. Here, a few ETAL used SVM and Volgive used k-nearest neighbor technique for prediction of electricity consumption of buildings, while others like Surets used LSTM and Shapi used several techniques such as artificial neural network, support vector machine, and k-nearest neighbor. Apart from this, Hamilton used radial basic function regression, support vector machine, Reptree, multi-layer perception, and Gaussian process. And Gonzalez-Brion's ETAL, support vector machine regression, linear regression, decision tree, random forest, and k-nearest neighbor method. Several experiments were performed by each author to achieve high-performing machine learning models to predict electricity consumption of buildings. This slide represents some more authors such as Somu ETL, Suranta ETL, and Firdosh ETL, Dong, and Farik ETL, who used mainly neural network based technique to predict electricity consumption pattern of buildings. Most researchers made use of techniques such as LSTM, CNN LSTM, LSTM RNN, multi-perceptron models, ARIMA model, Holt Winters, support vector machine, support vector regression, linear regression, decision tree, random forest, and k-nearest neighbor technique to predict electricity consumption pattern of buildings. But use of assemble techniques such as stacking regressor that combines several ML models is little explored. This project will address the gap by developing ML model using stacking regressor combining several ML techniques. The project has been completed using CRISP methodology, and this methodology provides a structure for planning, execution, and evaluation of data mining projects. It offers high adaptability as per the needs of project and possesses cyclical nature that helps to achieve continuous improvement in project. The first phase of CRISP DM methodology is business understanding, and this lays down scope of the project by defining aims as well as the objective of project. The machine learning model will be created in this project using historical data set of energy consumption by various appliances to train and test models. The model will be evaluated through use of accuracy metrics such as RMSE, MAE, and MSE. The data for purpose of training and testing of ML model has been sourced from Kaggle, and it contains 19,740 records related to electrical consumption of the house of period of 4.5 months. The frequency of the data set is 6 data points per hour, and there is 29 feature in data. Appliances is targeted in data set. The descriptive analytics of the data will be performed to get understanding, and the data and visualization will also be developed to understand relation in different variables. In the data preparation phase, the data is prepared to make it suitable for developing of ML. The cleaning data was done in this phase, and missing values and inputted the mean of the column. Apart from this, outliers were addressed by clapping values, and data was split into the ratio 70-30 for purpose of training and testing models. The machine learning model will be created using three techniques, including linear regressor, random forest regressor, and a stacking regressor technique. Stacking regressor will combine two base models, including random forest and linear regressor. Linear regressor is a technique that can be predict the value of target variable, that is appliances on basic of one or more input features. Random forest regressor is built on various decision tree during training, and average prediction of the individual decision tree is taken as output to make prediction. Stacking regressor combines prediction from various base models using meta model to improve accuracy prediction. The evaluation of the three models, including linear regressor, random forest regressor, and stacking regressor, will be compared using several accuracy metrics. Will be done using RMSE, MAE, MSE, MAPE, and R square. RMSE indicates the standard deviation of prediction errors, while MSE shows average of the absolute difference between predicted and actual value. On the other hand, MSE shows average of the square difference between predicted and actual values, while MAPE presents average absolute percentage error between predicted and actual values. R square value indicates proportion of variance in the dependent variable from the independent variable. Data analytics. Analysis of data was done, and correlation matrix was created by using Python to understand relationship in different variable. T1, T out, and wind speed shows positive relation with target variables. That is applies while press M, MHG, and RH out shows negative relation with target variable. This graph presents the line chart using Python to analyze monthly trend in consumption of electricity in buildings. The consumption of the 100.9 watt hour, which is the highest consumption, can be seen in the end of the February month, while the lowest consumption of the energy is seen in the month of June with the value of 94.2 watt hour. The bar plot shows consumption of energy in watt hour with respect to hour of day. The 19th hour of the day was maximum consumption of energy. The consumption of energy is now 190.4 watt hour. The third hour of the day has minimum consumption of the energy. The energy consumption is 48.2 watt hour. This chart shows the consumption of appliances electricity with respect to indoor and outdoor temperature. The highest energy consumption when outdoor temperature range was 15 to 17 degrees Celsius, while the highest energy consumption in there in indoor temperature range of 21 to 23 degrees Celsius. This chart shows consumption of energy with the respect of atmospheric pressure. The atmospheric pressure range of 730 to 740 mm has highest appliance electricity consumption of 120.5 watt hour. This figure represents the bar chart of the consumption of energy by the level of the humidity. The chart indicates that the average energy consumption of 210 watt hour when the humidity level is 60 to 70%, and it is 89.5 whatever when the humidity level is 30 to 40 percentage. Consequently, it has been inferred that the consumption of the energy of the increase with the increase of the level of the humidity. There is zero energy consumption when the humidity level is between 20 percentage or more than 70 percentage. This figure represents a bar chart of the consumption of the energy with the change in the speed of wind. The chart indicates that there is average energy consumption of 118.1 watt hour when the wind speed is between 6 ms to 8 ms, and 83 watt hour when the wind speed is 0 to 2 ms. Result of ML model. The comparison of performance of three models has been shown in this slide. The MSC and MAE, RMSC, MAPE, and the R square value of stacking regressor is lowest among all three models. Therefore, it can be referred that this model is provided the best performance. This slide presents the predicted versus actual value graphs related to consumption of electricity by all three models. It can be observed that predicted are closest to actual value in case of stacking regressor, which indicates that it provides best performance. Since stacking regressor offers the best performance among all three models, so it was used to predict electricity consumption of the building for 7 months of 2024. The highest energy consumption is predicted on the month of May. The project can be highly significant in enhancement of electricity consumption efficiency of building by predicting demand of electricity in advance. This can help to avoid brownouts and blackouts. Machine learning model to predict electricity consumption of domestic building has been created by linear regressor, random forest, and stacking regressor. The performance of all three has been compared, and it has been found that stacking regressor offers the best performance, and it combines two ML technique of linear regression and random forest regression. And here are some reference that I listed. Now I am showing my product, which is a machine learning model that I have created for predicting the energy for a domestic building. And as you can see, this is my code. This is a code, this correlation matrix for selected variables. This is a monthly trend for appliances energy consumption. Uh, in the end, when I run the final code, I'll get a CSV file which shows the actual and predicted values, and which have 3,947 entries, and these are like for the each and every day actual and predicted values. And if we need to enter manual values, that also we can do that. I have demonstrated in the circle. As you can see, I have given few values, and I got a predicted energy consumption of 125.57 watt hour. Thank you.